Hi, my name is Ms. Darine and I will be going through the subtopic 3.2, which is maxima and minima, also known as the extreme values. So let's go through some basic terms and definitions that you might need to know. It's just that maximum and minimum values of a function on an interval are also called extreme values. This just means that extreme values are a fancy word to describe maximum and minimum values. So don't be scared when you see the word extreme values. So some types of extreme values that you will encounter is the local minimum, local maximum, absolute minimum, and the absolute maximum. So what do they mean? The local maximum is basically, it's not the highest peak, but within an interval, so let's say within this interval, it is still the highest. And the local minimum is the same except it applies to the lowest one. So let's say it's not the lowest of the minimum, but within the interval, it is still the lowest. And as for absolute minimum, it's the smallest value of a function over the entire domain. And for the absolute maximum, it is the largest value of a function over the entire domain. And you have to note that there is no local maximum or minimum at the endpoints. So this is the endpoint and this is the endpoint. Notice how this endpoint is an absolute maximum. It's not a local maximum or a local minimum, and this endpoint also. So let's talk about the algorithm for finding extreme values. If f(x) has a derivative at each point in the interval a to b, we have to calculate f(x) at all points in the interval ab, where f prime x, which is the derivative, equals to 0, and the endpoints x equals to a and x equals to b. The maximum value of f(x) on the interval a to b is the largest of these values, and the minimum value of f(x) is the smallest. So this is a lot of words, so let me just sum it down into the next slide. So these are the steps that you will have to do in order to basically find the extreme values that you're looking for. First, you have to find the derivative. Then you have to set the derivative to equals to 0, and you have to solve for all the values of x. These values of x are called critical numbers. Ensure that the x values found are within the intervals given. If it is not in the given interval, we do not need to proceed with the next step, and we do not need to evaluate it. So, after we ensure that they are all within the intervals given, we have to evaluate f(x) for all the x values found and the endpoints given. Compare all the y values we found from step 4, and the largest value is going to be the absolute maximum value, and the smallest value is going to be the absolute minimum value. Pretty simple, right? So let's start with an easy question. The example 1 states that determine the maximum and minimum values of the function f(x) equals to x cubed over the interval -2 to x, -2 to 2. So first we have to find the f prime x, the derivative. So we found that it is 3x squared, and then we have to set the derivative equals to 0. So after we set it to equals to 0, we have to isolate to find x. So this is very simple calculation. I hope you guys know how to do this, but let's go through it. So first, we have to divide it by 3 on both sides to get rid of the 3 here. And then we have to square root the x squared to get rid of the squared here. And then what we're left with is x equals to 0. So after this, we have to evaluate the x values and the endpoints that we were given. So when x equals to 0, your y value is 0. When your f equals to -2, when you plug it in, your y value is -8. And when your x equals to 2, which is the endpoint here, your y value will equals to 8. So from all these calculations, we can compare the y values, and we will find out that this is going to be the minimum value, and this is going to be the maximum value. So we have to write a statement at the very end. The max value is 8 when x equals to 2, and the minimum value is -8 when x equals to -2. So I hope that makes sense. So let's go through a little bit of a harder question, which is example 2. Determine the maximum and minimum values of the function f(x) equals to 2x cubed plus 3x squared minus 12x plus 2 over the intervals -4 to 2. Okay, first, it's very simple, like I talked about. We find the derivative. The derivative is 6x squared plus 6x minus 12. So I'm not going to go through how you do the derivative. I hope you already know. That's like the prerequisite for this 3.2. And then you set the derivative equals to 0. After you set the derivative equal to 0, first you common factor the 6 out, so you're left with 6 bracket x squared plus x minus 2. And then you factor the middle again, so you get x plus 2 and x minus 1. And then you isolate to find for the x, so the x you'll get is negative 2 and 1. And then you have to, so notice how negative 2 is within the interval and 1 is also within the interval. That means we can proceed and evaluate it using fx. So you can write this however you want. I prefer putting the endpoints first and then putting the values you find later. So first you evaluate f to negative, f is negative 4. So the y value you will find is negative 30. And then when you evaluate for x equals to 2, then the y value you will find is 6. And then f, when you evaluate x equals to negative 2, which is the value you found here, you will get your y equals to 22. And then when you get you evaluate x equals to 1, and then your final y value will be negative 5. And when you compare all these 4 y values you find, you will realize that when x equals to negative 4 and your y equals to negative 30, that is your absolute minimum. And when your x equals to negative 2 and your y equals to 22, that is your maximum. Okay, that's not so bad. So let's move on to a harder question. And this is going to be the last example in this slide. So it says determine the maximum and minimum values of the function fx equals to 4x over x squared plus 1 over the interval negative 2 to 4. So the first thing you'll need to do is you'll need to find the derivative. So then we will have to bring out our trusty old friend, which is the quotient rule. I hope you guys know how to do the quotient rule for this one. So first you have to do, you just copy and paste the x squared plus 1, and then you find the derivative of your 4x, which is 4, minus 2, you copy and paste the 4x over, so minus 4x, and then you find the derivative of x squared plus 1, so it's 2x, and then you put the bottom, your denominator, into squared. So it's pretty simple. And then you expand your brackets, and then you will get 4x squared plus 4 minus 8x squared. And then you will have to collect the like terms, and you will end up with your final derivative, your simplified derivative, which is negative 4x squared plus 4 over bracket x squared plus 1 squared. So then you set your derivative equals to 0. And when you set it equals to 0, you have to know that we only need to consider the numerator when we have a fraction. So when you use the numerator, you put negative 4x squared plus 4 equals to 0, and then you isolate it to find your final x value, your critical number, which is positive or negative 1, plus minus 1. And then you have to evaluate it because it is within the interval given. So first you evaluate the endpoints. When x equals to negative 2, you plug it into your fx, and you find that it is negative 8 over 5. And then when you plug 4 in, you find that your y is going to be 16 over 17. And then finally, you plug in your critical numbers that you found. So when you plug in negative 1 into your fx, you find that the y value is negative 2. And when you plug in x equals to 1 into your fx, you find that the y value is going to equal to 2. So your maximum number, your maximum value will find will be when x equals to 1, so you get to 2. And your minimum number you will find is when x equals to negative 1, which is your minimum, gives you your minimum value, negative 2. So this is 3.2 is finally over. As you can see, it's very simple, and I hope you can go through the homeworks to help boost your learning and help you truly understand 3.2. It's not that very hard. Okay, see you in 3.3.